Hello and welcome to our next tutorial in this series on making a 2D scroller. And this is a short tutorial. We're going to look at movement. We're going to look at player movement and background movement. So I'm just going to press play here. This is our game. We're using the A and the D key for input. And my character moving, goes down, and you can see him having a little fly there, walking up the ramp, and then traveling before he lands. So he has a little bit of kind of skidding there. So we're just going to examine. You can see I've got kind of my level saved twice here, just so for different. We'll get to the other level in a minute. Different kind of methods. And so the first thing we're going to do is we're going to look at our player. So our player has a script called player movement L1, so level 1. And we'll look at our background. So our backgrounds don't have any movement on them. So I'm going to turn this off, this maximize on play, and I'm going to zoom out a bit here. And we're going to have a little look at how this works. I'm going to press play. And here's my sprite. I press left, I press right. If I zoom right out, so there's my level. So I'm moving backwards and forwards, left and right. Now, in this version of my world, the player is moving. The camera is not a child of the player. Camera has a follow script on it, so let's first have a look at that, because in the last tutorial we looked at or we've in previous tutorials looked at how to move the player. So let's go to camera follow, this one here. So basically it says there's a game object, and that game object is going to be our player. We've called it follow me, and we've basically said my position, my X position, is the same as the X position of this object here. Now that's interesting, because it doesn't mention Y. And if we look over here, we've got X is horizontal and Y is vertical. So let's just press play again and walk up this ramp. So I'm moving from right to left, but the player is getting higher, but the camera is not following. So if we were to make the camera the child of the player, and we walk up, then the camera would also ascend with the player, and then suddenly we have this large black area at the top of the screen, which in some instances you may want, but most of the time you don't. So this way we're duplicating the x-axis value of the player, so horizontal, but we're not doing anything with the vertical axis. So I can still jump, but the camera doesn't jump up and down with the player. So this is one way of doing it. You can see that the character has full, it can get up and down ramps and move. It does a bit of skiing, sort of a bit of sliding. We can fix that by tweaking the drag on the rigid body. Now let's have a look at how this player is moving. So the script is player movement 1. So let's have a look at this here. Now, in our previous tutorial when we moved the player, we had a speed, and the speed was a float, and we said transform.translate vector2.right times speed times time.delta time. Now that basically moves the character. So let's actually look at that again. So let's I have these commented out, so these double lines here basically mean don't read this line. So I'm going to save that, and we're going to see what happens. Now when I press play, now I can walk left. Now I'm not moving quite as quickly, but that's okay. I've got rid of my skiing there, which is excellent, or my sliding. But I've got a problem when I hit this ramp. Now I can't get up the ramp. Now I can fix that by increasing my speed. So now I can't get up the ramp. So if I want to instantly stop and start, but I want to get up the ramp, I have to give myself a decent velocity. Now I can increase the mass of the character, and the drag here, and I'll go down and I can still walk up. So this is sort of down to your preference. Also, like when we get a bit more complex, some methods are better than others. So in this method here, the character has to move at a higher velocity in order to have basically to be able to move up past this ramp. There is an alternative way to do it in code, and that is, rather than trying to give the character increase its transform, we can give it a velocity. So let's just have a think about the difference between these two ideas. So a transform moves a position from one coordinate to another. So if we look up here at position here, position X, so it moves it, say, from 4 to 5. And this speed is the velocity it travels at between 4 and 5. So if the velocity is great enough, when it hits a barrier, it'll still move up. So that's fine. But we have these sort of ceilings of velocity. If I go too fast, I'll have to increase the speed of the animation, and then we may traverse the level too quickly. If we want to be able to move slowly and still be able to walk up here, the method we use is this. So we're using velocity. And velocity is connected to rigid bodies, and only to rigid bodies. So the transform, you can transform any object. So any object, every object in the game, every sprite has a position, and we can move between two positions, and that's its transform, and that's its moving from one position to another. However, objects that are transforming don't necessarily have real-world physics. So what we're calling on when we use velocity here is we're calling on real-world physics, and hence when we use this method, the character slides. Because in the real world, there's things like friction, and I haven't saved that. So file, save. So we're swapping out now from using a translate to a velocity. So in this, version of it here, I can move a little more slowly, but I'll have, we need friction in order to slow me down. So in your game, you get to pick. Now we'll be looking at a later date at ray casting, and so we'll know when the character is in the air or not in the air, when he's touching the ground, and we'll be getting slightly more advanced versions of this. But at the moment, it's up to you which one you want to use. Now, if you see here, I'm kind of skiing. I'm moving faster than the animation is moving. We can always call up the animation window and make this say 12, and then when we walk, he's got slower, so we'll call it up again, animation, and then we'll go from 12 maybe to 30. And now when I walk, maybe so that the movement of the legs reflects the velocity I'm traveling at a little bit more. So if you need to match the velocity or the speed of the animation to the velocity of the character, you need to go to your animation window and change your frame rate to speed up or slow down the animation to correspond with the character movement. Okay, so that's one way of doing it. And we'll save the scene, and I'll load in another scene here. Now it looks like nothing has changed, but these are deliberately the same, but one or two differences. So in this version of the game, let's have a look and see if you can see the big difference. So in this version of the game, the character is not moving at all. The camera is not moving, nor is the character. The world is moving. And again, we have issues of climbing. But this technique, and we can overcome these issues by increasing the velocity of the character as well. So we can increase the, I've removed it from the script, but yeah, we can move so this background layer is moving. It's got a speed of 2, so we give it a speed of 6, and then we should be able to climb excuse me, climb up the ramp, just about. There we go. There we go. In this version of this implementation, or this method, whereby the character and the camera aren't moving, I still have my follow script, so that the camera is still following the player. So when the player moves up, the camera doesn't follow him up on the y-axis, so he's not a child. But in this version here, what we've done is, the script is called camera follow, so the same script. On this one it's called player movement 1A, so it's to correspond with this level here. So in this, the difference between these two scripts is, when I press my key, the character doesn't move. So he still flips left and right, and he still triggers the animation from the key input, but there's no motion. The motion is in these scripts here. So basically I'm saying here, when I press this key or this key, move the background. So all I've done is I've copied the movement component of this script out, apart from jump actually, so I can still jump. And then I've placed them in separate scripts, and then I've placed those scripts on the background. Now, the reason I have two of them is this is the speed of the background. So if we look back into the game, so this is my base here, and it consists of two sprites. It's the cables and the background, and then I've got this foreground, these pipes, these black pipes here, and they have a script on them. This one here, foreground movement, and that script is the same as this one, except it's got multiplies the velocity of the foreground item. Now in this case it's by 2, so let's just turn that into a variable. Let's call this go. And we'll go variable go is a float equal to 2. So that's pretty much the same thing, only we can access this in the inspector. So there's my foreground there, and I'll remove the component. Oh, I've spelt it incorrectly, so I'll put that on there. Go. Oh, I've put in 0. Fantastic, well done. So file, save, and it says background object none, and I've got so very quickly, if you look in here, so this says move. So here's my speed and move. This one's slightly more subtle. It says there's a background object, and I'm moving. So my position is the position of the background object multiplied by 2. So in here I need to, for this foreground object, I need to tell it what the background is, and the background is the base. Now what I'm going to do is I'm going to duplicate this, and this one here I'm going to give it a speed of 6. Actually let's go 8 just to exaggerate it so you can see it. And I'm just going to move these pipes slightly, these ones here. Now the beauty of this system here is I can have foreground and background items giving me a proper sense of parallax. So I have foreground and background items moving at different speeds to each other to get a sense of depth, and then we can tweak them individually. So I've given this a speed of 8, but that's too much, so I'll give it 5, and this one here we'll give it a speed of 3, and then the background, it has a base speed of, oh you said 6 there, let's say 2. So we're going yeah, so we'll just press play. So as I walk this way, you can see these items crossing over each other to give a sense of depth. So if you, so depending on the type of game you want to make, so if you want to make a game like Limbo, where there's lots of parallax, then you probably want the camera to stay still. You want the player to have a rigid body, the input to trigger the animations, to be able to jump up and down, but not to actually move the player left or right. If you're playing a game like Sonic, you probably don't want that. You probably want something closer to this, where the character has rigid body physics, and it moves and the camera follows. So just to show you, there is different ways to implement character movement. Like I said, we'll be doing more advanced sort of tutorials later in the year that show some advantages and disadvantages to both of these systems, and there's no reason why you can't take bits from one and integrate them with bits from another.